In this video, I'd like to talk about the Pythagorean trigonometric identities. And to understand these identities, we need to start with the unit circle. And remember on the unit circle that it's called the unit circle since it has a radius equal to 1. Let me redraw that. And with this circle, we have seen in a previous video that we can define the trig function sine and cosine based on the x and y coordinates along this circle. And we will define them using an angle theta that is measured positively from this positive x-axis. If we count rotating counterclockwise, that's a positive angle. And if we count clockwise, that would be a negative angle. And the x-coordinate is the cosine of the angle, and the y-coordinate is the sine of the angle. And from this, we can use the Pythagorean theorem to come up with a relationship, an identity between the sine and the cosine function. And the way to do that is to construct right triangles, since the Pythagorean theorem involves right triangles. So let's start by dropping a vertical line here that is perpendicular to the x-axis, and we will construct a line that is parallel to the x-axis that goes to this vertical line here. And you can always construct a right triangle from any point on this circle here, where the hypotenuse is always the distance to the origin, and you just have to drop that vertical line and construct that horizontal line. Now, from this right triangle, we just need to understand what the height or the vertical component and this horizontal component are equal to. And we know that this point goes up to a y value, which we'll just call y, and it goes over to an x value, which again we will just call that x. But we also know that y, the height of this line, is the sine of theta. So this vertical length here is simply the sine of the angle, and this horizontal length, similarly, is just the cosine of the angle, since the cosine and the x value are equal. And from this, we have a right triangle, which, let me quickly redraw it here. This triangle has a hypotenuse of length 1. We know the horizontal side is the cosine of theta, and the vertical side is the sine of theta, where, again, theta is measured right here. And remember that when we have a right triangle, any right triangle, the Pythagorean theorem says that when we take the legs of the triangle next to the right angle, we square them and add them together, that they are equal to the hypotenuse of the triangle squared. So the cosine and the sine, these are the legs. We can call these A or B. It doesn't matter which we call which. But the hypotenuse, the side opposite the right angle, this is always C in this formula. And we can now just plug all of these in. We have the sine of theta, and we will square that, and we'll add this to the cosine of theta, which we will again square, and this is equal to the hypotenuse squared, or 1 squared. And we can simplify everything. There's a convention we use when we write the sine and the cosine to different powers. We would write this as the sine squared of theta, where we put the square after sin. And we will write this as cos, and then the square of theta. This is just, again, the cosine squared of theta. And all of this is equal to 1, since 1 times 1 is 1. And this right here, let me just make some more room. This is the first of the Pythagorean identities. And again, they're called Pythagorean because they are derived from the Pythagorean theorem. Now, there are actually 2 more of these Pythagorean identities that we can derive from this equation, and those relate the other 4 trig functions, but we will look at those in the next video.